and welcome to the BEDMAS. I hope you're ready for some math for today, and we will start with the first chapter, which is dedicated to elementary calculus. Today we will introduce necessary notation and definitions that will help you to read and write mathematical information in clear, short and precise way. So we will have a look at set of numbers, intervals, elementary algebra rules and some fractions. We will start from introducing sets, numbers and basic calculus. So basically, what is the set? Set is a collection of distinct objects that we call elements. Let's say we have some arbitrary set X. It contains some elements A, B, and C. So these three letters belongs to set X. We can write it in the following way. As you may see, we write all the elements in the curly brackets and separate them with a comma. So since A is element of X, we can write it as A is element of X or A lies in X. You see, we use the special sign here. On the other hand, let's say there exists letter D, which is not element of our set X. In this case, we can write it as following. We denote that D does not lie in X, or D is not element of X. You see, it's the same sign, but we cross it. And we denote it like this. There's also possible that set does not contain any elements, so we call it empty set and use this special sign, or we just leave the curly brackets empty. These both notations are suitable to write the empty set. It is possible to write a set in several ways. For instance, we want to have a set between 1 and 13. First of all, we can write it just like this. Curly brackets and write down all the elements belonging to the set. Or we can also use 3 dots and instead of writing all these numbers here, we just replace them because we know there is a similar pattern exists. So that's why we can just replace it. Or we can also use a vertical bar and write down set of numbers between 1 and 13 in this way. This is also possible. Generally, in set, it doesn't matter how often the element is listed. For example, these two sets basically are the same. So it doesn't matter how many times you list 1 or 2, these two are the same. And the ordering of the elements doesn't matter either. So you can write it 1, 2, 3, 3, 2, 1. It will be the same set. Okay. If we have two sets, let's say A and B, the new sets can be constructed out of them, such as union and intersection. Maybe you already remember them. So union is a set that unites A and B together. So it's denoted with this sign here, and we're interested in all area here that belongs to both sets because we unite them. That's why it's called union. As for intersection, be careful. It is easy to confuse these two signs, but it looks more like a bridge between A and B. And we only interested in this area that intersect. This is a common space between A and B, and it's denoted with this sign here. Also, there is a difference, or A minus B, which is denoted by the slash here, and which is very important, it contains elements of A without intersection with B. So we are interested here only in this area. So now, for the clearer understanding, let's have a look at this example, but already with numbers. Given the following set A and B, what do you think will be the union, intersection, and difference in this case? You can pause the video now and try to write down your answers and then come back to check with me. I will highly encourage you. Okay, I hope you are coming back now and we can check the answers together. So we will start with union. As you remember, for this example, the union will include all the numbers that we see together in A and B. 1, 2, 3, 4, and 5. Intersection will include numbers that both A and B have in common, which is 3 and 4. And finally, the difference would be the numbers that are present in A without numbers in the intersection B, which is 1 and 2. I hope everything is clear here and we can move on further. There are some general number sets that are labeled with special letters that are commonly used in mathematical notation. I'm quite sure you have seen them before, so let's refresh your memory. For this, let's have a look at so-called number line. We have here 0 as a reference, just in the middle, and on the right side we can place the natural numbers, which is set of whole positive numbers that we use for counting, like 1, 2, 3, 4, and we denote it with letter N. Normally, 0 is not included in this set, but if we want to include 0, we need to specify it and denote it as N0 here. It implies that 0 is also included in this set. So what's happening on the left side of the number line? So on the left side are located negative numbers on the same equal spacing from 0 as positive numbers, like here. The same numbers, 1, 2, 3, but we have a minus sign in front of them. And that's how we distinguish negative from positive numbers. So there is a set that includes natural numbers, 0, and whole negative numbers. We call this set integers and denote it with letter Z. I hope this is clear here. So if we take any two integers, for example, we take 3 and 5, and let's divide them by one another. And we get an expression that we call a fraction. So this we call a fraction. By the way, there's like several ways where you can note a division of two integers. Like here, you see there's different signs that you can use, but mainly you will see during your studies as a fraction form. So the upper side of the fraction is called numerator. So in this case, 3 will be numerator and 5 is called denominator. Please remember that it's not allowed to divide by 0. That's why denominator cannot be 0. Division of two integers, for example, if we divide 6 by 3, we get 2. 2 is located here in the number line. There's no problem to find its location. But what about 3/5? Where in the number line lies this number? It's not easy to say it just by looking at it. So how we find location? So we take 3 and divide it into the 5 equal parts. And one part will be 3/5. And as you may see, it's located somewhere between 0 and 1. Important to mention that integers, including 0, we can also write in a fraction form. For example, if we take 3, and we can just rewrite it as a fraction as 3 divided by 1. Or 0, we can say that 0 divided by 1. So in this case, we can rewrite natural numbers and integers as fractions. And there is a set that includes all possible combinations of fractions of two integers, and this set is called rational numbers and denoted by letter Q. Wow, this formula looks very scary to you, right? But don't worry, everything here we already seen before. P and Q, P here will be numerator, Q is denominator, and P and Q are integers, and denominator cannot be equal to 0, what we already mentioned before. As you can see yourself, it's not that hard to read formulas. As you remember, we can rewrite integers as a fractions. On the first side, it seems like Q includes all the possible numbers here, right? Not exactly. Sometimes there are situations when numbers cannot be expressed in a rational form. Wow. Let's have an example. We can construct a square of size 1. So this is a square. It has all the sizes are equal to 1 here, and we have a diagonal. So, and if we take this diagonal and then drop it to the number line, we will land somewhere that we call square root of 2, and this number cannot be expressed by fraction of two integers. Simply not. Nevertheless, this number exists. This number lies in the number line. And we call this kind of numbers as irrational. So it is not possible to express it as a ratio of two integers. So other example of irrational number are p and Euler's number. So the set, final set that includes all possible numbers, including rational numbers and irrational numbers, is called, like everything here, basically the whole number line is called real numbers, and we denote it with letter R. So let's have a quick review. Natural numbers are whole positive numbers. Boom. Yeah, easy. Integers are natural numbers plus 0 and plus negative whole numbers. So we can just include 0 here. Oops. Yeah, this is 0. And next is irrational numbers include integers plus fractions. Here we have them. And finally, real numbers are rational and irrational numbers. So these symbols R, Q, Z, and we use these symbols commonly in notation instead of writing very long sets. You remember we had this example of this very long set before at the beginning, and we can just rewrite it also using letters like this, or if we imply that x is element of all real numbers, we denote it like this. So now we are familiar with numbers, we can have a look at the basic operations we can perform with them. So basic operations of elementary arithmetics include addition, where summands result in a sum, subtraction, where minuend minus subtrahend equals to difference. Next operation is multiplication, where factors result in product. And finally, we have division, where dividend divided by divisor equals to quotient. Maybe you studied math in your own native language, which is not English, and you use different terms for naming the elements of basic operation. That's why I thought it's important to know them if you come up with them somewhere in the literature, so you will not be confused. So the order of operations, it's very important in a situation when we have several operations at the same time. For this, there is a rule that we follow, and it's called BEDMAS. And it just means brackets, exponents, division, multiplication, addition, and subtraction. It's just the first letters of them, then one expression, which is BEDMAS. Let's have an example because it's always easier to see on an example. So here we have an expression that has several operations. So first of all, we always start with brackets. And we start with brackets, we know that this is equals to 5. And next we skip exponents and division because we simply don't have them in our expressions. Next step will be multiplication. So we do multiplication here and here. Here will be 8 and here we have 25. And in the end, we do the final operation, which is addition. And now we have our answer and everyone is happy. While performing this operation, it's very important to remember a sign rule. So what are the sign rules? Firstly, the additive inverse of negative number is a positive number. This is very important to remember. And also, we can rewrite a subtraction as a sum of positive and negative number, and vice versa. In multiplication and division, two negative numbers result in positive. Please remember, it's only true for multiplication and division. Only for these two. If we have two minuses, they just cancel each other and we get rid of them. But if only one element is negative, as in here in the example, final result will always be negative. And you shouldn't be scared of this minus sign. Just treat it as your friend and don't forget it It's like a small tail that follows you all along the expression. You can move it everywhere you want, where it's convenient for you. But just don't forget, you cannot just get rid of it or forget it somewhere in between, which is a common mistake. Just keep it. So now I recommend you to take a short break, drink water, do some practice exercises, and when you're ready, come back for the next part.